What if I told you that you could build ChatGPT-like features into your Spring Boot application without paying a single cent to OpenAI and without your data ever leaving your machine? Hey everyone, welcome back to PRP Coding. I am Praveen Ravindran Pillai, and in this video I will show you exactly how to do that using Spring AI and a local LLM running right on your own computer. This is part 1 of my new Spring AI series. So if you are a Java or Spring developer curious about AI, hit subscribe because this series is going to take you from zero to building real production-ready AI applications. Let's get into it. So first, what actually is Spring AI? Spring AI is a project from the Spring team that brings the same philosophy Spring has always had: abstraction, portability, and developer productivity into the world of AI application development. Here is the problem it solves. If you have looked at building AI apps in Java before, you have probably seen people directly calling REST APIs from OpenAI or Anthropic or Google, writing raw HTTP calls, manually building JSON payloads, and hard-coding themselves into one specific vendor. Spring AI gives you a common abstraction layer on top of all of that. That means you get a unified chat client API that works whether you're talking to OpenAI, Anthropic Cloud, Google Gemini, Mistral, or like today, a local model running on your own machine through LM Studio. You get built-in support for prompt templates, structured output mapping, function or tool calling, and retrieval augmented generation with vector stores. And because it's Spring, it plugs straight into Spring Boot auto configuration, dependency injection, and the whole ecosystem you already know. So the big idea is write your AI logic once and swap the underlying model with basically a one-line config change. Today, we are going to swap in a local open source coding model, Qwen3 coder. So there is no API key, no internet dependency, and no cost. Let's build it. Here is the plan for today's demo. First, we will install the LM Studio app and pull the Qwen3 coder model locally. Then, create a new Spring Boot project with the Spring OpenAI starter. Then configure the application.yaml file to point at our local model. Then, inject a chat client interface into a simple REST controller. And finally, we will hit our own API endpoint and get a live response from the model running on our local machine. Simple, focused, and by the end, you will have a working local AI-powered API. Now, open the LM Studio app and click on this model search icon. Here, you can see a library of models. Search for whatever model you want to use. Here, I am going to use the Qwen3 coder 30 billion parameter model because it is specifically trained for coding and runs beautifully on Apple Silicon. I have already downloaded this model. Now, based on your hardware configuration, select an appropriate Qwen3 coder model and click download. This will take a few minutes depending on your internet speed and the model size. Once the model has finished downloading, click on the developer icon. By default, you should be redirected to the local server tab. If you are not, simply select the local server tab manually. Next, click the load model button. Choose the model you downloaded earlier, okay, and then click load model to start loading it into memory. After the model is loaded, you will notice that the server status is set to stopped by default. Here you can see the status is stopped by default. Simply switch it on to start the local inference server. Once the server starts successfully, you will see a message similar to reachable at followed by a URL and port number. See, here you can see that. This is the URL and the port number is 1234. This indicates that your local LLM is now running and can be accessed from your machine. In my case, the model is available on port number 1234, which means any compatible application such as Cloud Code, Light LLM, or other AI tools can communicate with this local model through that endpoint. Now, let's see how to create this project. First, create a Spring Boot project via IDE or Spring Initializer. Then, we will add just two dependencies, Spring Web and OpenAI. That's it. No additional libraries are required. I have already created this project and opened in IntelliJ IDE. Next, let's configure our application. Under the SRC, main, resources, open the application.yaml file. Here you can see that I have already configured it. Notice the API key. It provides the authentication credential that Spring AI includes with every request it sends to the AI server. When Spring AI communicates with an OpenAI compatible API, it expects an API key because the OpenAI requires one. LM Studio follows the same API format for compatibility, so Spring AI still sends an API key in the request. However, LM Studio does not validate the API key by default. It simply expects the field to be present because the OpenAI client requires it. As a result, you can use any non-empty value, and here I have specified as LM Studio. The most important configuration is the base URL and the model name. The base URL tells Spring AI where it should send all of its AI requests. By default, Spring AI sends requests to OpenAI servers on the internet. When you set base URL equal to http localhost:1234/v1, you are overriding the default behavior and telling Spring AI, don't send requests to OpenAI. Instead, send them to the AI server running on my own computer. In our case, that server is LM Studio. LM Studio exposes an OpenAI compatible API, meaning it accepts the same request that the OpenAI API does. As a result, Spring AI can communicate with LM Studio exactly as if it were communicating with OpenAI without requiring any code changes. Then, the model name must exactly match the model we loaded in the LM Studio local server. In this project, I have created a chat controller. Here, we are using constructor injection, which is the recommended way of injecting dependencies in Spring. The interesting part here is what we are injecting. Notice that we are not injecting a chat client. Instead, we are injecting a ChatClient.builder. So, the obvious question is, where does this builder come from? Spring AI automatically creates it for us. During application startup, Spring Boot reads our application.yaml file. It sees properties like the base URL, API key, and the model name. Using this configuration, Spring AI creates and configures a ChatClient.builder bean and registers it in the Spring container. So, when Spring creates our controller, it sees that the constructor needs a ChatClient.builder. Since a bean of that type already exists, Spring injects it automatically. When we call builder.build, Spring AI creates a fully configured chat client. We store that instance in our controller and reuse it for every incoming request. The builder acts as a factory for creating chat client instances with whatever defaults our application needs. Once the chat client is created, we simply use it throughout the controller. Now, let's look at the API endpoint which accepts the user prompt. Everything we have done so far, creating the project, configuring application.yaml, and injecting chat client was just preparation. The actual AI interaction happens in this single line of code. At first glance, it looks like just a Fluent API. But behind the scenes, Spring AI is performing several operations. Let's understand them one by one. The chat client is the object we created in our constructor. Remember, this is not just any Java object. It already knows everything about our AI provider. It already knows the base URL, the model, the API key, which HTTP client to use, which JSON serializer to use, the default options like temperature and max tokens if configured. So, at this point, Spring AI already knows where to send the request and how to communicate with the model. Think of it like a configured REST client or web client. The prompt function starts building a new AI request. Notice something important. Nothing has been sent to LM Studio yet. No HTTP request has been made, no tokens have been generated. We are simply creating a new prompt. Think of it as opening a blank conversation. Internally, Spring AI creates an object that represents the conversation. Initially, it contains nothing. The user function adds the user's message to the prompt. Spring AI converts this into a chat message. Again, nothing has been sent yet. We are still building the request. Now comes the most important method. This is where everything happens. Until this point, nothing has left our application. As soon as we invoke the call function, Spring AI begins executing the request. Now, what JSON is Spring AI generating? You never write the JSON yourself. Spring AI generates something very similar to this and then sends it to exactly the same endpoint that OpenAI uses. LM Studio implements the OpenAI compatible API. That's why Spring AI doesn't even know it's talking to LM Studio. From Spring AI's perspective, it's just another OpenAI compatible server. LM Studio receives the request. The model predicts one token at a time until it completes the answer. LM Studio wraps the generated text into JSON and sends it back. The response from LM Studio is not just a string. It contains a lot more information like chat response, assistant message, token usage, model name, finish reason, metadata, and so on. So when you call the content function, you are telling Spring AI, hey, I only want the assistant's text. So if the response is like this, Spring AI extracts only the message content and returns it as a simple Java string. Now, let's run the application and test it via Postman. The application is running at port 8080 and let me invoke the chat endpoint with the request parameter prompt with the value explain Spring AI in 50 words. And let me click send. Wow, you got the response from the local LLM. Now, let's try another prompt like explain DI in Spring under 50 words and click send. Congratulations! You have just built and executed your first Spring AI application using completely local large language model. No OpenAI API, no cloud dependency. Everything is running locally on your machine. In this video, we focused on building the simplest possible Spring AI application. In the next video, we will go one step further. If you find this video helpful, then please like, share, and subscribe to my YouTube channel and stay tuned for the next updates. Thank you.